This lesson explains the relationship between lines that are parallel and lines that are perpendicular. Parallel lines are lines that never intersect. They travel side by side, moving in the same direction. So it makes sense that parallel lines have equal slope. For example, both of these lines have slope equal to 2. Perpendicular lines are lines that intersect at a right angle, or a 90-degree angle. The slopes of perpendicular lines are negative reciprocals of each other. This means two things. First, they have opposite signs. One is positive and the other is negative. And second, they're reciprocals or inverses of each other. For this example, one is 3 over 2 and the other is 2 over 3. There's another way to identify perpendicular lines. Lines are perpendicular if the product of their slopes is equal to -1. For this example, 3 over 2 times -2 over 3 is -6 over 6, which you can see equals -1. By the way, although these lines are perpendicular, they may not look perpendicular depending on the aspect ratio of your viewing screen. Notice the lines y equals x plus 3 and y equals -x plus 1 are perpendicular. The first line has a slope of 1 and the second line has a slope of -1. Since the number 1 is the only real number that's a reciprocal of itself, the slopes are negative reciprocals and the lines are perpendicular. However, be careful. This is not true for other integer slopes. Notice 2 and -2 are not negative reciprocals. For example, the lines y equal 2x plus 3 and y equals -2x plus 1 are not perpendicular. 2 and -2 are not negative reciprocals of each other. Finally, y equals -3 is a horizontal line through -3 on the y-axis, and x equal -2 is a vertical line through -2 on the x-axis. These lines are perpendicular, but they don't have negative reciprocal slopes because the slope of a horizontal line is 0, and 0 doesn't have a reciprocal. There are two interesting questions related to parallel and perpendicular lines. Question 1. What's the equation of the line through a given point parallel to a given line? Question 2. What's the equation of the line through the point perpendicular to the given line? The place to start with these questions: graph the given line. Starting from standard form, subtract 2x from both sides of the equation. For -y equals -2x plus 3. Then divide both sides by -1. For the equation in slope-intercept form, y equals 2x minus 3. Then graph the line starting at -3 on the y-axis and going uphill with a slope of 2. Then graph the given point 2, -3. For question 1, a line through this point parallel to this line would have the same slope equal to 2. So starting at 2, -3, graph the line going uphill with a slope of 2. To find the equation of this line, use the point 2, -3, slope equal to 2, and substitute into the slope-intercept form of a linear equation. You get -3 equals 2 times 2 plus b, which is -3 equals 4 plus b. Then subtract 4 from both sides, and you have b equals -7. So the equation of the line is y equals 2x minus 7. So here's the given line y equals 2x minus 3, and the given point 2, -3. The equation of the parallel line is y equals 2x minus 7. And you can see this is correct from the graph, since the y-intercept of the line is -7 on the y-axis. For question 2, a line through this point, perpendicular to this line, would have negative reciprocal slope equal to -1/2. So starting at 2, -3, graph the line going downhill with a slope of -1/2. To find the equation of the line, use the point 2, -3, slope equal to -1/2, and substitute into the slope-intercept form. You get -3 equals -1/2 times 2 plus b, which is -3 equals -1 plus b. Then add 1 to both sides, and you have b equals -2. So the equation of the line is y equals -1/2 x minus 2. So here's the given line, y equal 2x minus 3, and the given point 2, -3. The equation of the perpendicular line is y equals -1/2 x minus 2. And you can see this is correct from the graph, since the y-intercept of the line is -2 on the y-axis. This lesson explained the relationship between lines that are parallel and lines that are perpendicular. This lesson was brought to you by the Math Fun Academy. Its continuing mission: to explore strange new worlds, to seek out new math and new equations, to boldly go where no math student has gone before.